Hello everyone. This is a supplementary session to follow up from my appearance on the Ask an OpenShift admin with Red Hat on episode 54, discussing all things OpenShift on VMware. My name is Dean Lewis. I'm a cloud solutions architect. You can follow all of my OpenShift on VMware content on my blog, theeducate.co.uk, and you can also drop me a message at SaintDLE on Twitter. So I'm going to cover a high-level overview of OpenShift together with VMware and a number of those infrastructure integrations that you can have out of the box with your VMware platform that you've got deployed today. I'm going to talk a little bit about common practices and issues that always come up when discussing running OpenShift on top of VMware. Then we're going to dive in some of those infrastructure pieces that we also want to know and learn about. So consuming your vSphere storage using OpenShift, integrating with the VMware networking stack, and also how you can provide infrastructure up monitoring through the vRealize suite today. So as a top-level view of where OpenShift joins together with VMware, I've decided to put together a few examples based on working best together with VMware Cloud Foundation. So for those of you that don't know, VMware Cloud Foundation is our software-defined data center solution, where we bring together our best of breed VMware infrastructure components, give you an easy reference architecture to deploy and repeat in your company. It keeps you up to date for the validated versions of the software that's being deployed. More importantly for yourselves, if you are using VMware Cloud Foundation today, then there's a number of these products that will integrate with your OpenShift environment straight away. If you are just a normal vSphere users today, and you may have some of these supplementary products as well, you will still get the benefits and the integrations there. It was just an easy way for me to package some of this information together. So the first one is obviously compute and the resource level. So at VMware, for a number of years now, we've had reference architecture available in the VMware Validated Designs, or what's been rebranded the VMware Validated Solutions, that cover running OpenShift on top of platforms such as VMware Cloud Foundation. And if you want to look into a little bit more depth as well, we also have joint architecture design guides with our partners such as Dell for running VMware Cloud Foundation and VxRail and putting OpenShift on top there as well. The number one question that I always get asked is about vMotion support, which is the ability to move virtual machines whilst they're running between hosts within your vSphere cluster. vMotion's always been supported by Red Hat. You will now find a statement supporting such within the OpenShift documentation as well. It is important to note, though, however, that storage vMotion is not supported at this current moment in time. Storage vMotion is the ability to move a running virtual machine between the data stores or the LUNs in your vSphere environment, so those VMDK files between data stores. That is not supported at the moment within the OpenShift environment, but vMotion is moving it between your compute nodes. Of course, one of the areas we're going to touch today is the ability to have actual storage integration with underlying VMFS volumes of vSAN and associated vSAN file services. And that's the ability to not just have the virtual machine files, so the VMDKs used for the nodes themselves beyond the underlying vSphere storage, but also any of the container-based storage that you're using inside of the OpenShift platform as well. One of the other areas is cloud provider support. So when you do a installer provisioned installation for OpenShift, it has the ability to talk to your vCenter. And that gives you some cool options, such as being able to create machine set configurations. You can specify which template to use, where to bootstrap. You can scale up those replica nodes and so forth. And that's actually the first area that I'm going to concentrate on now as a demo. Okay, so we're connected in my lab environment, and we're going to be connected to one of my OpenShift clusters that I've deployed in my vCenter. So the first thing I'm going to do within this OpenShift cluster is I'm going to find out the machine set details. So that's really easy. We can do OC, get machine set, and in the namespace of the OpenShift machine API. There's only one machine set deployed today, and this is the out of the box I've deployed my environment. But if I want, I could also create an additional machine set, and then I could also then configure the machine pool config to use that machine set going forward. And I also have a little bit of a blog explaining how to do this and how to modify these machine sets in more depth as well, which you'll see in a link coming up on the video in a second. So let's explore that machine set in a little bit more detail. So I've just run the OC machine set name, and I've just output that to the YAML file. So if I go down, we can see that at the moment we've got a replicas of 2, so that's going to create 2 worker nodes in my environment, all the machine labels that have been created, and then if we go down under provider spec, this is where we're going to see more detail. So we're going to find out where our vSphere credentials that we need to use to create these additional virtual machines, so we'll authenticate to the vCenter. We're going to set the disk size, the memory, and the number of CPUs, and also the networking that we need to attach that virtual machine to. And then where we're going to place that within our VMware environment as well. And then if we want to scale this up, so I'm going to change it so I've got 3 worker nodes. If I do OC get nodes, we'll see we've got 2 currently. I'm going to change that to 3. And it's as simple as just using the replicas equal 3 to set that new configuration there with the scale command. If I now go to my vCenter interface, so I'm just looking at my cluster, I'm looking at the overall tasks, and we can see straight away that we've started to clone my virtual machines. That's the template that we were referencing before. And then as that goes on, if I start to refresh this page, once the clone's completed, we'll start to see that the virtual machine's powered on. You can actually see some of the other actions from earlier on today when I was testing this before creating this video. If I look at my events page as well, and I refresh this event, we can also see here we've got our new worker name that's been deployed. We can see that we've then started the virtual machine, that it's powered on. Once the virtual machine is powered on, it's going to have that guest ignition data in the virtual machine that allows it to bootstrap to the cluster. So we just have to wait for a couple of minutes for that then to become available within the environment. I go to my virtual machine now, I can click on the Launch Web Console. And then we can see it's going through the bootstrap setup as well at the moment. You may see a couple of emissions on there as it starts to bootstrap as well. Don't worry too much about that for troubleshooting straight away. Obviously, after 15 to 20 minutes, if you're not seeing the virtual machine come up in your cluster, then that's when you start troubleshooting. But for the first minute or two, you're going to see it go through a number of messages there. Okay, so if I now run the OC get nodes, I had it running with a watch command on previously. We can now see that my additional worker node has come up in the cluster created by changing that machine set. Took roughly about 15 minutes in my environment to bring that up, and that was really simple. I'd run out of DHCP spaces in my lab, so unfortunately there's no address for the worker node when it came up. I quickly fixed that with DHCP, rebooted the worker node that had been deployed, and everything bootstrapped and came up after that. If we then go back through this command, I can also remove replicas in the environment as well. So I can scale that back down to 2 replicas. And then what's going to happen when I start to look at OC get nodes is it's going to remove a random node from the environment as well. And it's going to move those workloads about in the environment. So that's kind of the first integration and cool things that you can take advantage of. So let's move back to the slideshow. Okay, so the next thing that we're interested in is the underlying networking. And for me, this is one of the biggest and most interesting parts of the integration with OpenShift. So we have support for NSXT integration, both with the networking container plugins. This is the NSX native integration itself. That was part of NSXT for a number of years now. Then we have Antrea. This is an open source project that's part of the CNCF, but we do have an underlying integration that's now available for NSXT if you're using Antrea as well, and we'll talk about that in a couple of slides. From a monitoring point of view, we have what I co-term the infrastructure up monitoring. So that's the ability to use things like vRealize operations, so you can go beyond your vSphere environment and see into the Kubernetes environment as well. That's really handy when working between teams in your business, so that you can understand, hey, what is a pod? Where does it run in my Kubernetes cluster? And is there something going on at the virtualization layer, maybe CPU contention that's causing problems for the pod to get the right resources to run its containers and services? And of course, a big part of that as well is logging, and we can bring Kubernetes logs into vRealize logging type using the open source FluentD configurations. And then finally, automation, another area which comes up quite a lot. Within vRealize Automation, we do have some limited out-of-the-box native support for older versions of OpenShift, but to be completely honest with you, we integrate on a number of fronts with any conformant Kubernetes environment, and that gives you the ability to have self-service capabilities, CI/CD delivery via our infrastructure pipelines component called CodeStream as well. Not going to touch too much on automation in this session today, but again, I've got some blog posts covering how to deploy an OpenShift cluster in an API fashion using VRA, and in the future, you'll probably see some more content come out from me around that as well. Okay, so let's cover some common practices and issues. Well, realistically, everything from a virtualization environment and a deployment still applies. OpenShift runs as virtual machines on top of the vSphere environment. So everything that you have to think about in terms of designing and deploying and managing a virtual machine applies when running OpenShift on the environment. You need to get those things right first before you think about that Kubernetes layer itself. So you need to think about the use of resource pools, and if you're putting reservations in place. The use of limits, we always recommend at VMware to not use limits in your environment, mainly because it's very easy to misconfigure them and can cause resource contention, even if your cluster's got available resources as well. So always really think about any usage like that in your environment. The biggest one for me is your ESXi cluster resources and contention. So think about the use of high availability. The default configuration in Kubernetes to monitor and offline a host in your environment, a Kubernetes node in your environment is 5 minutes. With VMware HA, if a virtual machine dies for whatever reason, HA can reboot that virtual machine in 60 seconds or so, which means it can bring it up and make it available against the Kubernetes cluster before the Kubernetes cluster realizes that that node has gone offline. That can be very powerful, but at the same time, your operators need to know and understand that behavior. Think about distributed resource scheduler. So that's the ability to move virtual machines about based on their requested resources. It's a very powerful tool. Pretty much all of our VMware customers use and take advantage of that today. We need to think about it from a settings point of view using anti-affinity. Because one of the areas that you want to ensure that happens is that your compute plane nodes are not sat on the same host. So you want to set some rules in place to ensure that they are sat on different hosts in the environment. So if you lose a host in your vSphere cluster, then it doesn't take down your whole Kubernetes compute plane and control plane at once. And then think about high performance as well. You might have dedicated hardware, or you might have nodes within your cluster or a separate cluster which got bigger, better CPUs, high, more performant RAM in there. So first thing is think about low latency. So you may need to toggle on that low latency switch on the virtual machine itself, so that VMware can identify it as a machine with highly transactional workloads there. But also think about your NUMA configuration as well. So that's how your virtual machine takes resources from the environment at the virtualization layer and then has its pathways through the memory bus architecture to the CPU as well. And there's a lot of great information from VMware and others out there on the web talking about NUMA configuration as well. And again, all these things we've just talked about apply to normal virtual machines, not just your OpenShift platform. Okay, moving on to storage. So the two areas we're going to cover is the vSphere Cloud Native storage plugins that we have, and also the vSphere Kubernetes driver operator, which makes life a little bit easier for you to lifecycle and manage those plugins as well. So the first areas that we want to cover on is the ability to have cloud native storage inside of vSphere and utilizing the underlying VMFS and vSAN architecture. So at a normal vSphere level, you've got your VMDKs and files being stored either on block storage or now with file services using vSAN. And you may have even set up storage policies at the vCenter layer as well to identifying the number of different storages and their capabilities underlying in that vSphere environment. So you may have storage LUNs which have encryption turned on, for example. One of the missing pieces through the control plane of your Kubernetes environment is that ability for your applications to create persistent volumes and then store them at the underlying vSphere environment rather than going off to another storage array. By using our cloud native storage plugins, the vSphere CSI, we give you that ability. It creates a cloud native storage control plane inside of your cluster, and then it connects it to the vCenter environment so it can take advantage of those underlying data stores, LUNs, and storage policies. You can then configure storage classes within your environment to be used by your application administrators and your Kubernetes administrators, and those can be backed again by storage policies or those data store LUNs. And essentially then when I'm requesting to create a persistent volume via a persistent volume claim, it can bind it to that underlying vSphere storage, which is fantastic because it gives you the ability to get the value and benefit at the vSphere level really easily and simple as a Kubernetes consumer. However, to deploy and manage that sometimes can be a little bit either daunting or hard to do. So we've produced the vSphere Kubernetes Driver Operator, or VDO for short. It gives you the ability to automate the lifecycle management of the vSphere drivers. It gives you compatibility support, so we're going to look at your Kubernetes environment and figure out the best versions to deploy that are supported by VMware. It gives you the ability to upgrade those drivers in the future. We, for vanilla Kubernetes clusters, we do also have a command line tool, which makes it easy to manage those things as well, rather than going into the manifest of Kubernetes itself. And it's agnostic at the networking layer when we deploy these as well. So a very high level architecture. So we deploy a control plane. We've got the VDO controllers themselves. They also produce their own custom resource definitions. And by configuring those custom resource definitions, we're going to deploy the vSphere CSI and also the vSphere CPI, so the cloud provider interface, which then gives the ability to interact and understand how we connect those persistent volumes to those worker nodes that are being deployed. One of the fantastic things when it comes to Red Hat is we've got the certification for VDO with OpenShift. This was actually, the VDO was created using our IBM Joint Innovation Lab, which is an area focusing on VMware, working better together with IBM so that we can integrate with their systems, services, and the Red Hat platforms as well. As a customer, you can reach out to your VMware or Red Hat or IBM representative and ask for more details about the Joint Innovation Labs, but also if you've got areas of pain or that you want to see further integration with as well, we'd love to hear your feedback in the future. As an overall, because we're certified with Red Hat, it means you're able to deploy and manage this through Operator Hub. In 5 kind of high-level steps, of course, we've got the installation of VDO through Operator Hub. We create a vSphere secrets, that's how do we get access to the underlying vSphere environment. We configure the configurations to connect to the vSphere environment. We configure the VDO configurations, how to push out the CPI and the CSI itself. And then we constantly check for that driver status against the compatibility matrix we have in place. If you update that compatibility matrix, then that's going to give us the ability then to reconcile against the drivers and status that they've been deployed with and then update them in the future as well. So, okay, so I've done quite a lot of speaking there, so let's move into a demo so you can see this as well in action. Okay, so this is my OpenShift I think 4.9 deployment in my lab. So first things first, to get started, I'm going to do all this through the UI, but you can also consume this through the CLI and the OpenShift API as well. It's just easier and nicer for a demo recording to do it through the UI. So if I type in vSphere, we're going to see we've now got this vSphere Kubernetes driver operator. And then I've already installed it, but it's really easy. It's the same way to install it as any other operator. We recommend that you put this into its own namespace or OpenShift project. Once it's installed, you've got a couple of things to configure. So our documentation takes you through this. You will have to set up some SEC configuration so that we can get the right level of access within the Kubernetes cluster when we deploy the manifest to generate the CSI and so forth, because we are going to be controlling them underlying storage constructs, which needs us to have a higher level privilege within the environment. We also ask that you create a Kubernetes secret with your vSphere credentials in there so that we can access the online vCenter, so that we can say, hey, create us a persistent volume as well. Once we've done that, we've got 2 instances to create. So the first one is our vSphere cloud config. And all we're doing here is pointing it at where our Kubernetes secret is stored and the underlying vSphere configuration that we want to connect to, so our vCenters and data centers, for example. Then we create a VDO config, and that's really simple as well. So all we're doing here is provide a name, and then for our storage provider, we're going to point to where our credentials are stored. We're going to tell it what Kubernetes distribution is involved. If we are using any custom kubelet path, typically for an OpenShift environment, you wouldn't have that anyway, which is okay. We're going to use that underlying vSAN storage and want to use the vSAN file services. Then there's some configuration there as well about the right permissions to access and the URLs of those data centers as well, so we can take consumption of that. And then if we're going to set up a cloud provider as well. So cloud provider is the mandatory requirement. If you already set this up outside of your environment, then you don't need to do this again. But if this is the first time you're setting up anything with the vSphere storage or underlying vSphere architecture within inside of your OpenShift environment, then you will need that CPI. And then we can set topologies for that regions and zones. And then again, if you've got separate credentials for connecting to the cloud provider just for least privilege access, then again, you can add in a secondary in there. And then that's it. Once that goes off, it's going to create the configurations, and then our reconcilers in the background through our VDO controller manager are going to look at the environment and manage through there. So if I go into my pod details, I want to look at the logs, and if I go to my manager environment, it's basically going to keep reconciling against there. And if I scroll up, let's see if we can see a little bit of that configuration in the background that went on previously. So this has been running for a while in my environment now, so I think these logs might have gone over. So quickly, I'm just going to see if I can bring up the older logs. So in my older logs here that I've already had open, we can see here we've found our available nodes within the environment. We can see it's then reconciling for the CSI and CPI. As it goes through, it's then going to start to deploy those as well. And from my compatibility matrix, it's also going to find the right YAML paths to actually deploy the CSI and the CPI in the environment as well. So I'm using the driver 2.4.0. But using the operator, we also have the ability to do offline installations as well. Once that's up and running in my environment, all I need to do is go into my storage classes. I'm going to create a storage class itself. And in that storage class, I'm going to point it to the CSI environment. Because I'm running on a VMware Cloud and AWS environment, I need to specify my data store URL as well. Set my reclaim policies in my binding mode. And then once that's happy, I create a persistent volume. If I just change this project to all projects, you can see I've created one already. And inside of here in my YAML, all I'm doing here is I'm specifying the CSI that I want to use when I deploy this PVC. And then it's going to become bound and attaches a VMDK file, or also known as a first class disk, into my virtual machine. That's my worker node, so that I can use it with my pods going forward. Okay, so that's a high level overview of the vSphere driver operator to make managing the storage integrations a lot easier for you as an OpenShift admin. So now we're going to tackle integrating with the VMware network stack. So the areas we're going to be focused on today is NSXT, Antrea, and a little bit on the the NSX Advanced Load Balancer, also known as Avi Networks formally. So this is the overall VMware modern app connectivity portfolio. As you can see, there's a number of areas where we provide connectivity services, connectivity into the underlying infrastructure itself, and then an overlay of features as well. We're going to be focusing today's at these two areas, so the ingress, which is the NSX Advanced Load Balancer, and also the host networking. In the future, probably do something around these other areas as well. So VMware has two container network interface offerings. We have the network container plugin, and then we have Project Antrea. So at high level, the NCP allows all of your workloads connected directly to the NSXT control plane and policies enforced by NSXT running inside the hypervisors. So your Kubernetes cluster becomes part of your underlying overlay and control plane for your virtual machines and Kubernetes cluster as well. NSXT is a requirement for the transit and enforcement, whereas Project Antrea is an open source project and slightly different. So whether you don't need to have NSX in place to use Antrea. Antrea is going to be deployed and managed at per cluster level, and these clusters can exist in public cloud as well, as not just your underlying vSphere estate. So for me personally, that's very powerful. Your virtual machines, if you do have NSX in place, are going to be connected to the underlying data plane. Pods connected to policies enforced within the open vSwitch data plane with inside Antrea. So it's going to be separate. So they're not part of the same overlay. However, you can use NSX when you've got Antrea deployed in the NSX 3.2 release to control the policies created with Antrea as well, which we're going to talk a little bit about in the moment. So let's look at some more of the key capabilities of when you'd use the NSX container plugin. So your Kubernetes construct is going to be mapped to the enterprise networking constructs within NSX. There's a number of topologies that we support around rooted, source NAT, NAT, destination NAT, and it's going to be per namespace as well if needed. From a security level, we can create your Kubernetes network policies, or you can admin define them within an overall security policy within NSX itself. You've got load balancing capabilities. This is kind of one of the big areas that you won't have just using Antrea out of the box, unless you're using Antrea with something like the NSX Advanced Load Balancer separately, which we'll talk about as well. And that gives you the ingress and service type load balancers inside of your environment. You've got end-to-end network topology visibility and troubleshooting and security controls as well. And again, if you're going to use NSXT to manage your Antrea policies, you also get some of that, which I'm going to show you in the demo as well. Essentially, you're going to get that single pane of glass across your whole VM estate, bare metal, and multiple Kubernetes and clusters. For deployment, we have a OpenShift operator available to make it really easy when bootstrapping and creating your OpenShift environment to bring up the NCP within there as well. So Antrea, in a little bit more detail, it's a CNCF sandbox project. It's a network plugin which provides pod connectivity and network policy enforcement using Open vSwitch inside of Kubernetes. And the focus here is making life really simple from a usability and diagnostics point of view within your Kubernetes environment. Adapts to any cloud, so regardless of where your Kubernetes or OpenShift environment is deployed, whether it's on-premise in your vSphere estate, using Azure, AWS, or beyond, and it provides you that comprehensive security policy and improving scaling and performance from a networking point of view. And you can connect with the project because it's open source in a number of ways. So you can go to antrea.io, you can tweet us. We've got everything tracked and open source through the GitHub pages. And then if you go to the Kubernetes Slack workspace, you can go to the Antrea channel as well. In terms of high-level overview, so if you're deploying Antrea, you're going to have an Antrea agent which manages the pod network interfaces and the opened vSwitch bridges, and that creates the overlay tunnels across your Kubernetes or OpenShift nodes, and also helps implement those network topologies. You can have a central controller, and that manages and publishes the custom resource definitions and the settings to those Antrea agents and aggregates all of that information from the agent layer. As mentioned before, Open vSwitch is the data plane itself, and this is all built from the ground up with Kubernetes technologies in mind. So we talked a little bit about the main thing here being the policy model. So out the box on the left-hand side, we've got the network Kubernetes policies that are available. On the right-hand side, we've got that extensions that the Antrea policies provide you. So you can have global policies bound to workloads across multiple namespaces, not individual namespaces. Priority orders, tier assignments, and additional actions such as allow, deny, and we're going to bring out further features in the future. A little bit more around that tiering. So we've got 7 static policy tiers, and you can also create custom tiers yourself through custom resource definitions. We have an evaluation precedence, and the default tiering is the application tier. And if we talk about that in a little bit more detail, so 7 out-the-box tiers cover across emergency, security operations, network operations, platform application tiers, Kubernetes policy tiers, and baseline tier as well. And then we have each precedence from there as well. And then we have a precedence from each of those as well. What does this mean from a usability model though? So let's look at this in a little bit more detail. So you've got configurable intent mapping. So what that means is your application developer or operators can use and deploy their own Antrea policies for their application themselves at the levels that they have access to. However, you may have your security team or your networking teams that need to set baseline or global policies across everything within the cluster, regardless of what your application users do, and you can have them in the separate tiers so that it fits in with the precedence model. which is really powerful because then it means that regardless of what happens at the application developer or operator here on the far right hand side, you can still override that within a other tier as well. You can then integrate this with NSX itself, and then NSX can become a centralized management across your Antrea based clusters as well. So as mentioned before, with the NCP, this is going to affect all clusters that are deployed and consume the NSX and load into the same NSXT manager. With Antrea, it's a per cluster deployment. So the policy is going to be per cluster, but the NSX firewall rules can be set across all of these clusters if you so want by bringing that management into the NSX integration itself, which then means your VI or network or security admins that use NSX can have that single control plane ability across all of your deployments. A little bit more around the integration with NSXT. So essentially what I've been talking about there is that creating policies and the visibility across your Antrea clusters wherever they run. So it becomes centralized from a usability point of view and becomes a single pane of glass across all of your container network and security management. And it gives you visibility across those clusters regardless of where they run. And then you can take advantage of things like using troubleshooting tools such as Traceflow, which is what I'm going to show you in a demo in a moment. Okay, so let's move into my demo environment. So I'm going to move into my Antrea folder where I've deployed it. I'm going to just show you very quickly some parts of the setup to actually bootstrap a cluster using Antrea. So if we look at my kube config file, it looks like every other kube config file that we've been happy with in the past. The difference here is I'm setting the network types on Antrea. I'm still setting a cluster network, machine sider, and service network. But when you do the OpenShift-install, we need to create the manifest folders before we run OpenShift create cluster to bootstrap that cluster. So we do support out-the-box IPI installation. If I look at my manifest files, so when you download from the GitHub folder, the Antrea, inside the deployment folder, there is a particular OpenShift folder, and in there we've got how to create the namespace, custom resources, and the operator itself. And that's all you have to do is copy these files into that manifest folder before you do OpenShift install create cluster. If you want to integrate with NSXT out of the box as well, there are some additional configurations that you can download from the my.vmware.com portal. Show you the folder for that. So we've got our NSX Antrea -NSX folder. There's a couple of other manifests that you would bring across as well. You will need to host the container image in your internal registry itself. And if you've ever done a bootstrap with NSX in the older days, you will need to also manually podman load that yourself as well. So if I just cat that file for us, I think I need to just do that as well. There we go. I missed the hyphen there. If I just try it again, you can see here what we're doing is basically telling it where to bootstrap the file from on each of the nodes to bring that up. In the future, we are going to bring this into the operator model as well, so it's easier to get up and running. But again, if you are looking to integrate Antrea with VMware, reach out to us if you need any assistance. Once that's up and running, your cluster's been created. I just clear my screen. How does this actually work and what does it actually mean from a usability point of view? So let's see it in action. So I have my typical application deployed today. So I've got a demo app, which is basically just the HIP. Sorry if you've ever seen that before out in the wild. And we're going to be looking at these two services that we're interested in today. So the front end and the payment service from a networking point of view. So I'm going to go to my website. Okay, so this is my Hipster shop that's being deployed within my environment. It's very simple. I can buy something, add it to a cart, and then I can place a dummy order as well, just to show connectivity between the front end and the back end services. Now, in my NSX environment, I want to see how this cluster shows up. So I'm going to click on my inventory first. I'm going to click on containers, and I can see all of the namespace that have been brought through from my Andrea environment. So I've got one for my OpenShift environment that we're interested in today, but I've also connected this to just a vanilla Kubernetes cluster as well. And with each of these namespaces, I can see all of the available pods. But if I view this from a cluster point of view, I can expand this out and I can see the number of nodes deployed within my cluster, the number of pods, services, and so forth. Now, because NSXT is managing this, it's going to be able to create my Andrea rules for me through the distributed firewall. So again, this is a simple environment, but I may have firewall rules in here that apply to virtual machines in my environment that use the underlying NSXT, but then I've also created some for containers as well. So I've got a dummy rule here, which basically is taking a source from any and destination of payment services, and it's allowing all the traffic. So this is why my Hipster shop works. But if I click within that destination, so let's see how it's created, I can see my effective members of 2 pods, and they come across 2 different clusters today. I can see the pod IDs and the cluster IDs that are within there. But if I look at the definition, the reason why that's happening is because I can now see all of the Kubernetes deployments, pods, services, and so forth, and see all of the tags associated with them as well. It's very simple. I've made a membership criteria which says any pod which equals the tag of payment services, and the scope equals a Kubernetes app from a discovered point of view. It applies for that for a grouping of that definition, which is one of the reasons why this affects pods within different clusters. If I want to just affect one pod in a set of pods within a single cluster, I could also include in my membership criteria which cluster I'm interested in. But for today's demo, it's perfectly fine that it affects anything with that pod. And I'm just very quickly just going to drop that traffic. I'm going to publish that. I'm going to click progress there because it updates very, very quickly. I'm going to go to my Hipster shop. I'm going to browse other products again. I'm going to try and buy a typewriter this time around. I'm going to place my order, and as you can see, it's not going through straight away. So whilst we wait for that to fail in the background from a services point of view, let's have a look at what's going on at a troubleshooting point of view through NSXT. So I go to the Plan and Troubleshoot tab. I'm going to go to Traffic Analysts. I'm going to go to Getting Started on the trace flow. I'm going to change this to my Andrea trace flow. So bear in mind, I'm only looking at the Andrea environment itself from a connectivity management point of view. It's not part of my underlying overlay with the rest of my NSXT environment. So I'm going to select it to my OCP cluster. I'm going to select my pod here. So I'm going to type in front end, and we can just select front end. And then I'm going to look at the payment service. And when I click trace on here, as this loads, we're going to see that basically it's dropped by network cluster policy. So this is what's stopping in my environment. I go back to my Hipster shop. We can see it also fails here, and it fails to connect to some of the internal services. That's one of the reasons why it's failing. So we're going to change that. I'm going to go back to the home screen. I go back to my security. I'm going to change that rule. And I'm going to allow that again. Now, one of the main things to realize here is that I'm setting this within the cluster itself. So this is pod-to-pod networking that's taking effect. If I now go back to my Plan and Troubleshooting, back to my trace flow, I'm going to retrace this now. I've updated that rule. And what we're going to see is that it's allowed, and the various configurations that it goes through, to forward that between the 2 pods themselves. So this gives you very granular control. If I go back to my Hipster shop, I buy my typewriter again, I add it to the cart, I place the order, it goes through straight away. So really, really powerful policy management control from that point of view. If you're not going to be using NSXT to manage the policies, then let's have a quick look at what you get out of the box with Andrea deployed within your clusters. So this is the documentation on the Andrea project in GitHub, and we've got a number of example policies with here. So if we go down, we've got some standalone clusters. We can set where we're applying to, so how we match against pod labels or node labels, setting ingress and egress rules, again, doing match selectors, where it's coming from, where it's going to. We can set IP block ranges and so forth as well. So very, very configurable. And we've got different rules and examples there for you. So for example, how to do pod isolation inside of a namespace, strict and full namespace isolation, zero trust models, for example, and service rules as well. Okay, let's go back to our slideshow. So the next piece, and again, I'm only going to really very high level touch on this for you, is ingress with service architecture for containers. So using our NSX Advanced Load Balancer, so this was our acquisition from, I think, around 2.5, 3 years ago, which is Avi Networks. We've got the ability to integrate at a Kubernetes level as well, using the Avi Kubernetes operator. So this gives you ingress controller functionality inside of your cluster managed by external load balancers that are deployed in software. It translates the Kubernetes objects into Avi controller APIs, and the operator runs as a pod inside your cluster for OpenShift. So when you do service type load balancer, that calls off to Avi and creates those services for you. And it gives you a nice, easy, scalable way to bring this into a full enterprise load balancing solution. So this is my Avi dashboard. It's already set up the front end that we mentioned previously. And we can see here at the minute I've got one pod configured. But if I go back to my environment in my terminal, one of the things that I can do here is I can scale up this pod as well. So in my environment, very quickly, I'm just going to scale this up so you can see it transform in the Avi Networks side of the house itself. So I'm going to do OC scale the deployment in the namespace of testing, and then set those replicas to 2. Oh, it would help if I spelled replicas correctly. So we can see that's now scaled to 2. So if I do OC get pods in the namespace of testing, we can now see I've got 2 front-end services. If I go back to my Avi environment, what we'll see here in a moment is we can now see that's changed when I've refreshed the page to 2 pods, and the Avi network is going to do all of the load balancing management from that point of view. So that's a very quick overview of that area. So now we're going to look at infrastructure up monitoring. So we're going to look at vRealize operations and vRealize log insights. So one of the important things for myself when I was a vSphere admin was how do I figure out where my container environment's running? So within vRealize operations, we have these concepts of management packs which extend the functionality of vRealize Operations Manager. We have a management pack for Kubernetes, and it provides you that infrastructure up view into your Kubernetes environment. I'm not going to show you how to configure this today, but it's really simple to get up and running, but I am going to show you my environment so that you can see the benefits that you get. Okay, so this is my vRealize Operations environment. I've already installed the vRealize Operations Management Pack and got that configured for you, but it's really easy. So we can add a new account for our Kubernetes environment. We provide the master URL, the collector service that you want to deploy. So I want to show you the differences between using a daemon set of cAdvisor, Prometheus server for additional functionality. Provide the credentials, and then the most important thing here is advanced settings and connect it to your vCenter server as well. So long as vRealize Operation Manager is managing the same vCenter where your Kubernetes environment is running, we can also do some interesting things there around linking stuff together. So I'm going to cancel out this. If I go back to my accounts, we can see I've got 2 clusters added in, and my status is okay, which is fantastic. I'm going to click on Visualize. We're going to go to the dashboard for Kubernetes that have been installed. So I'm already on my overview, but you also get a pod and container dashboard as well to dive into those. And then again, if you go to code.vmware.com, you can see other dashboards that the community has created, such as my colleague, Simon Conyard, who created one around Kubernetes namespaces from a point of view. I can then select either of my clusters that I'm interested in, and that should reset there, and then it'll bring through high level of the cluster, alerts, are cluster members healthy? So from a relationship point of view, I can then dive into each of my cluster nodes, properties, pods running on the nodes. I can bring through node properties and individual container properties as well. If I open this up and look at the metrics, we're going to see everything here if it's monitored by cAdvisor. But if we're using Prometheus to export the details to us using the Telegraph export agent, we can bring through Prometheus details as well. So that allows us additional data or application data from within the container as well. So if I open up Telegraph, for example, I can then look at, it's going to be ordered in container name, namespace, and pod name to dive into. So I can now see my containers, the cluster control policy, OpenShift Kube Control Manager, and the pod name is Kube Controller Manager. So if I scroll down here, let's see if there's one that's interesting to us. So somewhere I have, go back up. I think I had an Argo CD deployment, which I don't think I've got running. So sorry, I'm clicking on the wrong node. We go to worker node where my Argo CD environment's running at the moment. Because obviously it won't run on be scheduled on a master node, so that makes sense. I can see here, I've got my Argo CD. I can see each of my containers running within the pod to Argo CD. And then I can bring through additional data such as the CPU usage at a container level, memory usage, and so forth as well. And then I can chart those out on the right-hand side here. If I click into one of my nodes itself, so I want to do this through the environment view. So I'm browsing those objects. You can see here on the left-hand side, I've also then can start to match this against the underlying virtual machines and so forth. So if I want to start to chart out metrics at a pod, node, resource pool, virtual machine level, I can start to do that as well. So I get full end-to-end visibility. So if we take this node name, if I go back home, one of the reasons why this is really important for me, and it's usually one of my favorite features inside of VRealize Operations, is the troubleshooting workbench. So I've got my node. Actually, I've already done a recent search on it there. We can see if I type in the node, I can see it from various viewpoints as well. If I click into Kubernetes node, I can then set and see all of my, through my selected scope. I'm going to see it from a Kubernetes point of view now. I can then change that level, and it's going to bring in additional data as well, start to link that to the virtual machine, and all of that potential evidence is going to update for me as well. Okay, so the next piece to go through is around logging. So what should I do with my logs? So VMware has our infrastructure log analytics product, vRealize Log Insight. Gives you the visibility across your clouds and platforms, bringing structure to the unstructured data, and provides you intuitive dashboards and leveraging machine learning for faster troubleshooting. So I have a joint blog that I've wrote with a colleague at VMware and some of the Red Hat team around how to get all of this set up with Log Insight Cloud. You can also there's some changes under the hood, but you can get this working with Log Insight on-premise as well. So let's see this in action. Okay, so this is my Log Insight environment. I'm going to go to Explore Logs first and foremost, and I've obviously got a lot of different logs coming from the environment to begin with. Very easily, I can change this, and I'm going to type environment, and I'm going to set this to OpenShift for my logs that are being brought through. If I start typing OpenShift, it's all going to pull that out as a field from those logs for me automatically to make life a lot easier. I can see all of my logs that are being brought through. I can change this within, I can fully open up these logs and find out all the information that have been brought through, which node it's related to, and so forth. I can see the types of logs that are being brought through my search query over the last 5 minutes or whatever parameters I've put in. I can see if there's any alerts generated, which there's not in my environment. And one of the most important things where some of the AI and ML feeds into it is around alert trends. So this is a really cool feature. So I can start to see what types of alerts are new. So I have only just appeared within that 5-minute search because I'm very basic search here. Which ones are growing in trend? So we can see here that they're up 233% across the overall baseline when we're monitoring this environment. What I can do if I go back to the stream, for example, is I'm interested in this particular one. I can also click on here and then I can say, okay, let's create a metric from this. Let's view it in context. Let's extract some fields. If I click here on this one, I can do the same as well. So I can start to really build up on there as well. Or I can create a load of dashboards with all these different queries as well to visualize these data in different ways. So my colleague Manish has created a OpenShift dashboard that's available as part of the blog post with Red Hat. And we can see number of nodes, pods, containers, a little bit similar to the vRealize Operations Manager. And then I can also then add in additional ones. So I know that there's an issue in my environment around unattached volumes. So I can see how many of these logs are popping up. And I can actually just see a breakdown of these logs as well within the environment. So again, bringing structured, unstructured data, and again, it's going to be across your whole vSphere estate, but you can bring that data in for OpenShift as well to deep dive into those analytics side by side. If I move back into the presentation, so we're going to bring this to a little bit of a wrap. I've covered a number of areas today. So I've got a number of resources here for you to go to. Throughout the video as well, I've put a number of blog posts that you can also read from ourselves. I really hope this was useful. Please do get in touch with us either through your VMware representatives, your Red Hat representatives. You can also tweet me on Twitter, get in touch with me through my blog posts, or get in touch via various other contact methods as well, especially for the open source projects. So that brings it to a wrap. Thank you very much for your time today.